Hello, this is Ali Nasehi. Welcome to my YouTube channel. Here I'm going to talk about some random ICs that I've recently been working with. One of the ICs that I really like and I decided to be the first one is LT3763. This device is a 60 volt high current step down LED driver. Here we are going to just check features and some absolute ratings, and then we are going to uh, see how this IC works. Let's see from the application note. Here are some features. Accurately control input and output current, 6 volt to 60 volts input voltage range, wide output range up to 55 volts, very low shutdown current around 2 microamps, control pin for thermal control of load current, input and output current monitor and limit, open source and fault detection, PWM driver output for LED application, thermally enhanced 28-lead FE package. This device is a fixed frequency synchronous step-down DC to DC controller designed to accurately regulate output currents up to 20 amps. The average current controller will maintain inductor current regulation over a wide output range from 0 to 55 volts. Output current is set by analog voltages on the control pins and an external sense resistor. Voltage regulation and overvoltage protections are set with a voltage divider from the output to the FBP. The switching frequency is programmable from 200 kHz to 1 MHz through an external resistors on the RC pin or with the sync pin and an external clock signal. Input and output current sensing provides input current limiting and accurate measurement of these currents. The FB pin is provided for application requiring a peak power tracking function. Additional features include an accurate external reference voltage for use with control pins, an accurate UVLO or enable pin that allows for programmable undervoltage blackout hysteresis, a PWM driver for LED applications, output voltage fault detection, and thermal shutdown. Here is a typical application. As you can see, and we are going to discuss in the future how these pins work. Here I give you a summary of how this works. Here is the pin for enable pin or under voltage lockout. From we could just limit what voltage our IC can work throughout these two resistors. We could monitor the input current that we get from the power supply by these series resistors on the drain of the high side MOSFET. This 2.5 milliohm resistor. And here is the couplage capacitor, and here is our high side MOSFET and our low side MOSFET. We could regulate the output current throughout these two items, this inductor and resistor, series resistor. Through this series resistor, we could regulate our output current. As you can see, here is a MOSFET in series with the load, that is an LED. Whenever we give a 0 into PWM pin, this MOSFET is going to be open and our load is going to be open. Throughout these two components, these two resistors, we could just we could change our output voltage regulation. This pin is used for frequency, to set the frequency of the switching IC. This is for soft start pin. This is VSC. Uh, this pin is used for compensation of the device. Whenever you want all the things to work together, so you could just change the amount of this resistor and capacitor in order to compensate the whole circuits. This IC gives an external extra information into our microchip if you want, microcontroller if you want. Throughout this pin IVA monitor, we could just give an average, give our microcontroller an average input current that is measured throughout this resistor, and we could give an average input current of our output throughout this resistor into our IC. This control pin is used for changing the output current of the device, and it has an internal 3.3 volts to use in our device called V reference. Here is our pin functions. BG is the bottom fed gate driver that controls the state of our external low side power FET. Int VCC is the regulated 5 output for charging the boost capacitor in order to drive our high side MOSFET. Int VCC also provides the power for the digital and switching subcircuits. Do not force any voltage on this pin. Bypass with at least a 22 microfarad capacitor to ground. Int VCC current is limited to 50 milliamps. Shutdown operation disables the output voltage drive. Make sure that you're not getting more than 50 amps from 50 milliamps from this speed, because if you get more than this, it may damage this device. And another thing that you have to make sure is that you don't carry a lot of load from this pin so that it cannot drive the boost capacitor for the high side MOSFET drive. VIA in pin, V input pin. Input supply pin is that it must be locally bypassed with at least a 4.7 microfarad low ESR capacitor to ground as close as possible to the exposed pad of the package. EN or undervoltage lockout acts as an enable pin and turns on the internal current bias core and sub-circuits at 1.705 volts and turns off at 1.52 volts. The pin does not have any pull-up or pull-down requiring a voltage bias for normal operation. Full shutdown occurs at approximately 0.5 volts. If unused, the enable pin may be tied to VE. V reference buffered 2 volts reference capable of 0.5 milliamps drive, bypass with at least 1 microfarad capacitor to ground. IV monitor. IV is the inverting signal of the input current sense amplifier. This pin connects to the drain of the high side N-channel MOSFET FET and input current sense resistor. IV in P is the non-inverting input of the input current sense amplifier. This pin connects to the input supply Vin and the input current sense resistors. IV in monitor is the buffered output of the input current sense amplifier. This pin enables monitoring of the average supply current with an output voltage of 20 multiplied by the voltage around the resistor. The capacitive loading to this pin should be less than 1 nanofarad. The fault pin, output voltage fault detection pin for shorted or open LEDs. Internal comparators pull down this pin when the FB pin voltage is lower than 0.25 volts or higher than 1.16 volts, and when the inductor current is less than 10% of the maximum value, this pin should be pulled up to into VCC with a resistance higher than 10 kilo. FB pin, we don't it's for for controlling the output current of the system based on the input voltage. FB pin, the feedback pin is used for voltage regulations and over voltage protection. The feedback voltage is regulated to 1.206. When the feedback voltage exceeds 1.515, the over voltage lockout prevents switching. The GND pins, you should all connect the GND pins into ground of your system. The control 2 pin is thermally controlled input to reduce the regulated output current. And the control 1 pin, sets the regulated output current throughout those potentiometer. The maximum control voltage is 1.5. Above 1.5, there's no change in the regulated current. SS pin is the soft start pin. Place an external capacitor to ground to limit the unregulated current during startup conditions. The soft start pin has an 11 microamps charging current. When the voltage at this pin is lower than the voltages at control 1 and control 2, it overrides both signal and determines the regulated output current. Sense negative, sense positive. Those pins are used to sense the voltage around the output current sense resistor. VC pin is a resistor and capacitor connected in series to the VC pin to provide the necessary compensation for the stability of the average current loop. Typical values are 5K to 60 kilo for the resistors and 2.2 nanofarad to 10 nanofarad for the capacitor. The I series mount is the buffer output of the output current sense amplifier. The voltage enables monitoring the average output current of the LED driver with a voltage of 20 multiplied by the voltage around the output current sense resistor. The capacitor loading to this pin should be less than 1 nanofarad. The RT pin is a resistor from the RT pin to ground sets the switching frequency between 200 kHz and 1 MHz. When using the sync function, set the frequency to be at least 20% lower than the sync pulse frequency. This pin should current limited to 55 microamps. Do not leave this pin open. Sync function is the frequency synchronization pin. You could give an external clock to this pin to use it to drive your MOSFET with the external clock. PWM pin, the input pin for PWM dimming of the LEDs. When low, all switching is terminated and the PWM out pin is low. This pin should be connected to int VCC when not in use. PWM out, this pin can drive an external FET for PWM dimming of LEDs. The pull up and pull down impedances of the driver are 2.20 and 0.90 respectively. Do not force any voltage on this pin. TG pin is used to drive the top FET MOSFET, and the driver pull up impedance is 2.20 and pull down impedance is 1.30. Do not force any voltage on this pin. The W pin is used internally as the lower rail for the floating top FET gate driver. Externally, this node connects the two power FETs and the inductor. boost pin. The boost pin provides a floating 5-volt regulated supply